CAN protocol. CAN protocol part 10. That is CAN arbitration and priority. So this is a very interesting and important concept that you have to understand how the CAN protocol behaves with the priority and the arbitration. So the bus arbitration and the message priority. Here, CAN controller may start a transmission when it is directed and idle bus. This may result in the two or more controllers starting at a message at the same time. So this is where the arbitration concepts arise. So whenever the some few nodes start to send the message at the same time, then the receiver has to confirm that which message has to be that taken as a input as a first, that is the priority. So this conflict is resolved the way is transmitting the monitor the bus while they are sending. So how the conflict will be resolved? Before that, the as you know, the CAN is a multi-master communication. So the time the node can be considered as a slave node. So how it will works? So that is also the simple statement has been given here. If the node detects the dominant level when it is sending a recessive level itself, it will immediately quit the arbitration process and become a receiver instead. So for example, if I am sending some signal, but I can see the broadcasting is a different signal. Say for example, if I am sending the dominant level, but I am seeing something as a recessive bit has been coming as per the priority, then immediately I'll stop my transmission and I'll wait as a receiver. So once the particular message ended, then again I'll try to send my transmission if my priority wins. So this is how the CAN bus will decides whether the transmitter or whether which one is a transmitter or which one is a transmitter or which one is a receiver. That can be decided by this kind of small broadcasting stuff. Then here the bus arbitration and the message priority. Let's see here we have the just CSMA, C and wired and logic. So this is a wired and logic. Here we have node 1, node 2 and node 3, and here we have the final bus, that is the receiving end. So that is this receiver will decide whether it is which message has to be received. So for this we have three messages. So here we have one, it's a higher level is one, and it is a low, that is a dominant bit and recessive bit. So we have one like 0, then 1 1 0 1 1 all or 1 1 1. So this is what we have. Then not all or one, here one, then these things is not been visualized because the node has been loses its arbitration here itself. Here again 0 1 1. So this kind of data has been sent. Let's see how this data makes the priority of a CAN message by means of arbitration. So here we have 0 0 0. As you know, the it's a and logic, wired and logic, 0 into 0 into 0 0. Then 1 1 1, again 1 1 1 1. So here the answer is 1. So 0 0 0, here also 0. Then 1 1 1, again 1. So here 1 0 0. So this node has loses its arbitration, so this will be out of the competition. Now the challenge is which one, node 2 or node 3, which one transmits the message first. For that again we'll continue the competition. Here we have 0 to 0, again 0, then 1 1 1, 1 to 1 1, then here 0 into 1, here it is 0. So that node 3 also loses its arbitration. So node 3 loses its arbitration, so node 2 has won the competition. So the bus will confirms that we have to receive the node 2 data. So this is the id has been entered here. So this sequence you have to understand. So the id has been entered here. Then the control field will take care which the control field will take care the taking the control of sending the data that is in the data field. So here arbitration field has been completed. So after this arbitration field, the control field will take a control of transmitting the data which is present in the data field. So here this one also eliminates, this one also eliminates. That means it is not going bus off, this also not going bus off. This two will consider converted as a listen, that is a receiver. See, till here it is a transmitter, but as soon it loses its arbitration, it becomes a receiver. So this is what I thought to tell here in the last one. If the node detects a dominant level when it's sending a recessive level itself, it will immediately quit the arbitration process and become a receiver instead. So here these three acts acted as a master, but as soon this node 1 and node 3 loses its arbitration, so this has been converted into slave. So only these node 2 is a master, so these node 1 and node 3 has been accepted, right? Node 2 is a master and we have to receive the data sent by the node 1 and node 3. So this is how the arbitration and message priority works. Let's see another example with the same kind of graph, but here we have the few information. So again we have a SOF, that is start of frame. So we have, so here the in our previous tutorial you might understand that there is a differential voltage, there is a voltage difference in the can between the can high and can low. So this also can be defined here only, can high and can low. So in the can high and can low we have again the 0 0, it will be dominant, then 1 1 1 it will be recessive. So here it will be recessive, then dominant bit again recessive, then here it will node 2 will change go as a listener, that is it will go as a slave. So then again here node 1 and node 3 continue its race. Here node 1 also goes as a listener. So in this race the node 3 has won. So again, as you know, we it will take the control, then the data field start to transmit, others will receive. So these are all identifier, that's what you have to understand. These are all the identifier. Here we have the control field, here we have the data field. So I guess you are very good, very much aware on the arbitration field with the identifier. Let's have the few quick summary that you have to remember. The arbitration process is performed over the whole arbitration field, and when the data field has been sent, exactly one transmitter left on the bus. So that's what here and here. Here also only one transmitter has been left on the bus, and here also only one transmitter has been left on the bus. And very common question that I have been heard these days, like, so if two, if two nodes are being sent the same arbitration, what will happen? Actually in practice it will not happen. Because the while creating the signal itself it will not happen. So that if in the worst case, if it is if start to send, then it will check for the data. In data, if that both data are been different, then it will send the again error, there is a bit error can be broadcasted because the data bit has been conflicted the data bit. So that's what the thing. If it is a same data, then there won't be a problem, the same identifier, same data will broadcast because there will be no conflicts. So right, the arbitration, so only one transmitter is left on the bus. Then this node continues the transmission as if nothing, no error is transmission. The other potential transmitters try to retransmit the messages when the bus become available next time. No time is lost in the arbitration process. Say for example, if this node 3 has sent its data completely, then again node 1 node 2 will start to take part in the next transmitting competition. So if the arbitration again is becoming less or high, then it will lose it. So if it is less, the arbitration is priority is high, then the value is low, then it will win the race. So there is no time to transmit or retransmit. So it can keep on take part to transmit. An important condition of the bitwise arbitration is to succeed that no two nodes may transmit the same arbitration field. So that's what I said. The bitwise arbitration says that there is no two nodes may transmit the same arbitration field, then it will goes to the bit arrow. Since the bus is wired and the dominant bit is logically 0, it follows the message with the numeric lowest arbitration will win the arbitration. So this is what the quick summary, that whatever we have seen here, so that's what has been given in this context. So we have quick points, like it should be only one transmitter. If there is no time is lost in the arbitration process, then it will be the bitwise arbitration, that is no two nodes may transmit the arbitration field. And here it is the lowest arbitration field, that is the high priority is always be the lowest arbitration, because of the can is a dominant, there's a wired and logic, and the dominant bit always wins the race. So this is all about the can arbitration message. If you have any doubts in this, you can always contact us. Now next part will be continue with the CAN bus speed characteristics, that is somewhat very new concept that very few have been aware. So like what are the bus characteristics with the wired lens, so that will be more interesting to learn, as well as it will help you to enrich your concept with respect to the CAN protocol. So we'll see in upcoming tutorial. Until then, stay tuned and happy learning.